තමයි දැන් ඩෑෂ් එකක් ගන්න ID number එක.
ඒ කියන්නේ paper number එක නේ. Hello, can you hear me?
Yes, sir.
Yeah, please rename yourself with relevant to the paper number that you are going to present. That means the paper ID number shall be there, and maybe after that you can rename your name. During the session, you should be in online. We will play your presentation, but for the discussion, you should be available. I hope you got my message.
After completion of my 2-year diploma in agriculture program, I entered the OUSL BIS agriculture program for the continuation of my further education. As a person who engaged in the field of education management and industry training in Sri Lanka, I serve my valuable knowledge for OUSL as a visiting academic and industrial expert on a regular basis. Highly experienced, well-behaved and well-qualified staff members at my OUSL life. I think it was a very good opportunity to the continuation of my education under the field of agriculture.
academics, I was able to understand, experiment, as well as gain the most of advantages of open distance learning model offered by the Open University. So with this model, I was able to learn myself, experiment things by myself, and make that theories into practical as an engineer. So in that way, the academics in the Open University, as well as the facilities like laboratories, library, and all the other academic staff and non-academic staff, was very helpful to make our journey a success.
Began the journey with Open University soon as I finished my A-levels. Industrial exposure we got from Open University is priceless. Knowledge I gained was able to make me who I am today. And the theoretical knowledge and the technical knowledge was very beneficial and influential. Today, I'm a successful woman in my field, in my career, thanks to the degree I obtained from Open University.
Good afternoon, all of you. I would like to welcome all of you for the International Open University Research Session 2022. And I would like to introduce Professor Chatura Heras, who is the chairperson of this afternoon session, parallel session 1. I think Professor Chatura Heras is with us. And over to you, Professor Chatura Heras, to conduct the session. Professor?
Yeah. Can you? It's audible, Dr. Nadira?
Yes, Professor. You are audible.
Okay, right. So, good afternoon. Today is the online session 3, parallel online session 1. So, our theme is engineering and technology. There are 6 papers to be presented today. So, the first paper is paper ID number 4. The title is Design and Hybrid Power System for Rubber Tied Gantry Cans. So the authors are WKS Vijay Veera and R.H.G. Sasikala. So the R.H.G. Sasikala, so you can, so the presentation is going on now. So after that, we will have the Q&A sessions. Okay, Dr. Nadira, over to you.
Good afternoon all. Welcome for the presentation for IHours 2022. The research topic is Design of Hybrid Power System for Rubber Tired Gantry Cranes. I am Sasikala from Department of Electrical and Computer Engineering. Let's move to the presentation. So these are the content which I am going to cover throughout the presentation. In this figure, you can see a rubber tire gantry crane, a crane that is used in the port terminals to move shipping containers from one location to other. Normally, these RTG cranes powered up by the diesel generators mounted on it because we cannot take power from the external link due to its moving nature. And also, these gantry cranes are operated in poor efficiency. With poor efficiency due to several reasons. One reason is these are operated at constant speed irrespective of the load handled by the crane, and also in the container lowering process the motors are deaccelerated, but the regenerative energy are not effectively used, rather it goes through the resistor bank as the dissipated energy. So those are the main drawbacks of these RTG cranes. If there was suitable energy storage was in place in this device, this regenerative energy could be recovered and stored and can be utilized for the next lift. The main purpose of this research is to identify whether the possibility of the storing this regenerative energy in the energy storage devices and design and develop a new hybrid energy storage system. So, and also you can see the drawbacks and of the existing RTG cranes in this slide, and also since this use the diesel as the fuel, there is high CO2 emissions which will affect the environment as well. And main aim of this project is to design an energy optimized hybrid power system for rubber tire gantry cranes, and these are the objectives. Study existing power system of rubber tire gantry crane, design new hybrid system parameters, design new energy storage system using battery and supercapacitor, and they model the system in MATLAB and testing of the system. Let's move to the existing rubber tire gantry crane design. Since there are a lot of operations to be handled by the one of the RTG crane, it has several types of motors mounted on it. One is the hoist motor, and the gantry motors are there, and also trolley motors are there. These power ratings are actual power ratings used in the one of the gantry cranes in port terminal. This figure shows you the existing system of rubber tire gantry crane, where the diesel generator is the main energy source, which converted AC to DC, and all the energy in the RTG crane received from the other motors received through the DC bus through the inverters, And also these hoist motors in the deacceleration process, these motors dissipated to energy to the DC bus, and it dissipated as the resistor bank, through the resistor bank. And this is the new proposed system for the RTG crane energy storage system, where the conventional generators are replaced with the variable speed diesel generator with active front end unit, which we can control the speed of the generator as well. And also all equipments are connected to the DC bus, and the battery and the supercapacitor are connected to the DC bus through the bidirectional DC-DC converters. And also this hoist motor and other motors are connected to the RTG crane induction motor, are connected to the RTG crane through the inverters. In this research, we propose the quasi topology combined with the battery and supercapacitor as the energy storage devices in order to connect to these inverters to the motors. Here, as the energy management system, a quasi-driving induction motor with supercapacitor and battery are proposed. In this figure, you can see a normal quasi-topology through the three-leg inverter connected to the induction motor. Here we use L1, L2 split capacitors and C1, C2 split capacitors connected with the which replaces the conventional Z source inverters with the quasi topology. And here, as the switch S7, that the normal diode is replaced with switch S7, because in here, in the charging process, we need to restore, we need to charge the battery from the motor deacceleration mode, so that the energy should be flowed in the both ways. So the primary energy source here is the battery, and the secondary energy storage, as the secondary energy storage, we use the supercapacitor connected via C1 parallel with the C1 capacitor through the bidirectional DC-DC converter. So, so you can see the topology here. Let me explain the purpose of selection of this battery and supercapacitor, because the batteries are the primary energy source which has the higher energy density, and the supercapacitor acts as a secondary energy storage source which has high power density to deliver peak load demand in short period. Because in the lifting time we need the energy, high amount of energy that we can take it from the supercapacitor. So use also here use the quasi topology to connect these two energy sources to inverter through the inverter to the induction motor. In this figure, you can see the two modes of power flow from the motor to the battery and supercapacitor, and also the discharging mode in the lower figure, where it flows the energy from the energy storage devices to the motor operation. The first figure, it shows that once the motor is in the accelerated mode, the energy flows through the S7 switch via S7 switch to the battery, and as well the large amount of power flows through the supercapacitor when the switch SA is triggered, and through the bidirectional DC-DC converter, the large amount of energy is stored in the supercapacitor in that mode, charging mode. And also in the second figure, once the motor is in a motoring mode, where it hoist or lift the shipping containers, the battery and the supercapacitor both are discharged in order to get the energy from these storage devices, where the SB switch is now triggered, and the large amount of power flows through the bidirectional converter to the induction mode. Here, this is the Simulink model of the induction motor that we propose. You can see here the lithium-ion battery bank are connected to the quasi topology. Same way, the quasi topology, the part is connected to the supercapacitor also connected to the quasi topology through the bidirectional DC-DC converter, and all the voltage capacitor voltage control is implemented in the this block in the bidirectional DC-DC converter. and also the quasi topology is connected to the motor through the three-phase inverter, and the motor reference speed is controlled through this field-oriented control. And in here you can see the motoring mode, the output waveforms. The first one shows you the current in the motor three phases. The second one shows you the motor speed variation in the motoring modes. Third one shows you the positive torque variation in the motoring mode. And here you can see the first figure, the comparison of battery current and the with and without the engagement of the supercapacitor. Here the blue curve shows you the total current of both battery and ISC, and the red curve shows you only the battery current. Here you can see the battery is not stretched so much in the motoring mode, where the supercapacitor provides the large amount of current to the system. Second one also shows you the control of supercapacitor current, and third one also shows you the variation in the voltage of the supercapacitor. In the regenerative braking mode, this figure shows you the speed is becomes to 0, and the second figure shows you the current, and the third figure shows you the negative torque. And here also it shows you the comparison of battery current and the supercapacitor current with the engagement of the supercapacitor. Here also battery current is low with and the supercapacitor because the current here shows you the negative, because in this mode both devices are charging, and the control of supercapacitor current shows in the second figure, and the last one shows you the voltage of the supercapacitor. In here as the discussion you can see this using the supercapacitor and the battery bank, we can propose new energy storage system with quasi topology that can reduces the current stress of the battery during both motoring and the regenerative braking. And also this application of quasi with the proposed hybrid energy storage method able to reduce the number of components, conversion stage, and the increase the efficiency of the overall. As the conclusion, this research proposes a new battery and supercapacitor hybrid energy storage method for quasi topology within the quasi topology drive induction motor, and the battery acts as the primary power source, and the supercapacitor is interfaced to the inverter through a bidirectional DC-DC converter. And the simulation results shows that the advantage of having a hybrid power source which have an impact on increase the efficiency and also reduce the fuel consumption and emissions of the conventional RTG crane. And this also shows you the battery current stress is reduced, which contribute to exceed its life cycle, and it help to increase the longer run of the RTG crane. These are the references that we used. Thank you.
Okay, so now is the time for the questions and answers. So the participants can ask the questions here.
Shashikala, I have one question.
Yes, sir.
Now, basically, how do you compare the consumption of this system with the conventional one? How about if you think of now we are all facing energy crisis at the moment now. Now,
Yes.
in that point of view, how do you compare this thing with the conventional one?
Actually, this system will improve the efficiency definitely, because this helps to restore some part of regenerative energy without wasting in the energy, without wasting in the resistor bank. But in our research, we do not did the experimentally. We did that on the real crane, because this is only the simulation part. We done
Okay.
for only for the hoist motor, not for the other motors. So
Yeah,
definitely I can say that
but from the analytical point of view, what you can say is there will be a saving, isn't it?
yes, there will be saving.
Okay.
It's a fuel saving, Dr. Nadir, I think. Fuel saving is stress on that. Fuel saving. The other, I have another side to ask from Mr. Shashikala. I think that have you concern about the hydrocarbon emission, because that the diesel the fuel generators have that problem in the environmental side. So have you considered this one also?
Here for our research, sir, we didn't consider because we added only the supercapacitor and the battery, but didn't measure the existing because in the existing one only the power source is the diesel generator. Anyhow, it emits. In the new our proposed one, we have implemented supercapacitor. We have introduced supercapacitor and battery bank, which will reduce the time that used for the conventional DC generator operation. That will also reduce the fuel.
So you can compare the fuel consumption also, that in percentage wise, how much they reduce, no?
Yes, sir, yes.
Yeah. So is there any more questions from the participants? Okay. So I think that there are no more questions. So thank you very much, Mr. Sasikala, for your sending us the presentation. So thank you very much. Right?
Thank you, sir. Thank you.
Okay. Right. So next paper presentation is paper ID number 5. Design a solar piezoelectric hybrid street light system. So authors are Ms. R.H.D. Sasikala and Mr. M.A.D.J. Marasinghe. The presenter is Mr. M.A.D.J. Marasinghe.
Welcome everyone to the presentation under the title of Design a Solar Piezoelectric Hybrid Street Light System. Let's move to the introduction. Here are some major points of the project background. As we know, street lights in Sri Lanka consumes power from national grid. In Sri Lanka, peak demand is observed at night from 6:30 p.m. to 10:30 p.m. The cost of generation during peak demand is the highest. And also during power cuts there is no backup for street lights. Therefore street lights need to be powered up from a renewable energy source. It will help to minimize the peak demand and also to increase the reliability of the street lights. The aim of the project is design and implement a solar piezoelectric hybrid street lighting system. Here are some major objectives of the project. This hybrid street light system consists of two power sources, solar energy and relative wind energy due to moving vehicles. Relative wind energy is converted into electricity not by conventional electromagnetic generation. Here use the piezoelectric generator. A vertical axis wind turbine is used to convert the kinetic energy of relative wind energy to a rotary motion, and that rotary motion is converted to vibration by a shaking mechanism. The vibration applies mechanical stress to piezoelectric elements, and then piezoelectric elements generates electricity. Identifying the parameters of the piezoelectric elements, design and implementing the prototype are also major objects of the project. This is the block diagram of the proposed system. Relative wind energy is converted to electricity by piezoelectric elements, and the charging circuit stores the electric energy in the battery. Same way, solar panels converts the solar energy to electricity, and that energy is also stored in the battery, and the microcontroller controls the charging circuit and load circuit. This is the flow chart of the proposed system. Now let's move to the design of overall system. The proposed system consists of below major parts. The first one, structure. The structure is made with steel L bars and vertical axis wind turbine which is made with PVC. Generator, and generator consists of piezoelectric elements and shaking mechanism. Rectifier and Arduino controller. Solar panel, a buck converter used to step down the solar voltage, and a rechargeable battery to store energy, and LED lamps as lighting load. This is how the overall system works. Both energy sources contribute to charge the battery.
when the speed of the moving vehicles exceed about 20 kilometers per hour, relative wind has a considerable energy. That energy is absorbed by the vertical axis wind turbine, and then the shaking mechanism converts that rotary motion into vibration. This vibration applies mechanical stress to piezoelectric plates to generate electricity. Conventional rectifier and smoothing circuit harvest the energy generated by piezoelectric plates, and microcontroller feeds that harvested energy to the battery. Solar is used to compensate the power requirement of the overall system, and lighting system is automated. This is the vertical axis wind turbine. Vertical axis wind turbine is one of most important parts of the design. This is made with PVC and it has 3 blades. Each curved blade has a diameter of 150 millimeters and a length of 200 millimeters. The axis is supported to the structure via bearings, and as you can see there are 3 permanent magnets attached to the rotor with an angular difference of 120 degrees, and the linear gap is 65 millimeters. This is the generator unit. It consists of piezoelectric plates and shaking mechanism. Piezoelectric plates are bonded to spring blades using double side tapes. Double side tapes electrically separate these piezoelectric plates and metal structure, and permanent magnets are attached to the free end of spring blades, and the other end is rigidly fixed to the holder. There are 2 of these types of generator units which are placed in opposite side of the turbine axis magnets. When the turbine rotates, the repulsion force between rotor magnets and spring blade magnets results the vibration, and the magnet on free end performs as the tip mass for the spring blades. That helps to continue the vibration until rotor magnet applies repulsion force again and again. This is the rectifier and controller unit. The AC output of piezoelectric plates is converted to DC and stores in the battery by this rectifier and controller unit. Arduino microcontroller measures the voltage of the capacitor, and it controls the discharge of power to the battery and the lighting circuit as well. This is how results observed during the test. First, only one piezoelectric plate is tested and then added one by one to measure the voltage gain. As you see, when the number of parallel piezoelectric elements increase, the time taken to charge the capacitor decrease. Wind velocity is set to 3 meters per second artificially for testing purpose. With 3 piezoelectric plates, the voltage rise up to 14.2 within 600 seconds. This is how power of generator unit is observed at each configuration. Maximum power is observed at 4 piezo configuration, and it was 0.675 milliwatts. This is the plot of capacitor voltage, energy and power. At 10.45 volts, the observed power was 0.674 milliwatts. This is the discussion. The major challenge was to do the mechanical design. The mechanical design was to convert the relative wind energy of the moving vehicles to vibration. The friction loss minimization and harvesting this dynamic wind energy is also a challenge, because the relative wind of the moving vehicles is a turbulent flow. The power generation of piezoelectric elements that are available in the market is very low, and it is very difficult to handle piezoelectric elements. The ceramic layer of these piezoelectric plates cracks due to overstressing. When it cracks, it drops its power generation capacity. And the solar energy conversion was not a big task, and the main focus was developing the piezoelectric generation. For the prototype, we bought piezoelectric plates from the online market, and those were customized for several other applications. None of those were made for power generation, and had to select the most suitable one, but they are not the perfect solution for this for perfect selection for the design. That is why the power generation is comparably low. But we can add more piezoelectric plates together to gain more power, like PV cells in solar panels. This is the conclusion. Piezoelectric power generation is still under research level. Every part of the prototype plays an important role in the design. The energy conversion of the prototype is very low, and it is about 0.1%, because as I mentioned in the previous slide, these elements were customized for several other applications, and we used only 4 piezoelectric plates for testing. Solar charging only occurs at the daytime, and piezoelectric charging occurs throughout the day. By adding more piezoelectric plates to the generator unit, it is possible to increase the power generation throughout the day. These are the references, and thank you.
Okay. So now is the time for the question and answers. So you can ask the questions, the participants. Yeah, Mr. Marasinger, can I ask the one question? Yeah. So then, really, that it's a good, invention, because that it's a requirement in the country now to control the demand of the power during the peak time. So then, is there any limitation of using this your new installation? There may be the time limitation or the power consumption limitation. So how much the power, the watt of the bulbs you can use, either time or the power consumption wise. Do you have any idea regarding that limitation of using?
So in this case, we used only 4 piezoelectric plates, and the generated power was 0.6 milliwatt.
Yeah.
So we have to add many piezoelectric plates in parallel and series to gain more power. Then we can match with our requirement. We can match with the lighting load.
Right. So then the wind energy, the power generation is it's compared to the solar, the solar power generation, the wind energy one is very significant due to the moving of the vehicles.
Yes.
Right. Okay. Is there any more questions from the participants? Right. It seems there are no. Okay. Thank you, Mr. Marasinger, for your contribution. Right. Okay. Thank you very much. Right. So next paper is paper ID number 9, designing microcontroller-based accidental fire protection system for sugarcane plantations. So there are 3 authors in this extended abstract: H.C. Disanayake, Kumara Hapugoda, and Professor C.S.D. Silva. So you can hear now the recording of the presentation.
Good evening, everybody. I am Hasanjay Chandimal, the author of this research, and the other authors are Senior Professor Mrs. C.S.D. Silva, Department of Agricultural and Plantation Engineering, the Open University of Sri Lanka, and Mr. Kumar Hapugoda, Deputy General Manager, Human Resources at Lanka Sugar Company Private Limited, Pelladda. This project deals with the design of a microcontroller-based emergency fire protection system for sugarcane plantations. The title of the project is Designing Microcontroller-Based Accidental Fire Protection System for Sugarcane Plantations. The study location is Lanka Sugar Company Private Limited, Pellathe. These are the few facts about how sugarcane burning interferes with sugar production. Sugarcane is the main economical crop in the Mondragon district, and sugarcane burn is an undetermined sugar loss in sugarcane industry. Large quantities of dry leaves can be seen in sugarcane field, so therefore a small fire can turn into a big fire in a matter of seconds. Then turn the sucrose contained in the plant into acid. When sugarcane burns, damaged cane stalk infect the Leuconostoc bacteria. Leuconostoc bacteria is responsible for production of dextran. Large number of problems arise such as elongated sugar crystals, increase in viscosity of juice, and blockage of filters. Burn can directly decrease mills and boiler performances, and mills and shredder can be damaged. The heat generated here destroy all living plants and organisms that contribute the decomposition of the soil surface. Burnt cane can directly decrease mills and boiler performances, and mills and shredder can be damaged. If burnt cane fetched rain can determine fungal growth on cane stalks. These fungus use sucrose as their food source. Then recoverable cane sugar quantities. The reason to develop this project is, at present an accidental fires are controlled by Fire Brigade of Sri Lanka Sugar Company Private Limited. The fire detection method is, if the fire present in sugarcane field, persons who are in duties in field inform the fire unit. Fire identification, inform to fire unit, and response time of fire unit to control fire is too high. Because of that reason, the field was already damaged to the notable level when fire units reached the field. The proposed solution for that problem is design two systems to fire detection with fire prevention protocol and notification system to notify the fire brigade. Fire detection system installed in sugarcane field and the fire notification system installed in the fire brigade office. The system has two separate systems, which are field system and fire control unit system. This is a diagram of field system. It is installed in the sugarcane field, and it includes fire detection and fire prevention protocol. It has smoke sensors, heat sensors, IR sensors, air quality sensors, microcontroller, water pump, and GSM shield. These sensors are attached in the portable metal poles. Each pole contains 2 gas sensors, 6 IR sensors, and 4 PIR sensors. These poles are installed in the field at 14 to 20 meter distance. Arduino Mega 2560 development board uses the microcontroller. Microcontroller receives these sensor output data. Then microcontroller identifies fire and it sends message of fire alert and area to fire control unit system via GSM network. And water pumps spray water to the field. Pumps are used water from already installed water tanks of the field. This is a diagram of the fire control unit system. It has field indicators, microcontroller, GSM module, LCD display, and fire alarm. This microcontroller receives the fire alert via GSM module. Then microcontroller turn on relevant indicator bulb of the field and turn on fire alarm. LCD display shows GPS coordinate of burning field, which is already installed in the microcontroller relevant to the field. After this procedure, fire unit can identify accidental fires on the sugarcane field and its exact location to respond quickly. Drone team can follow the GPS coordinate to fly drone and get live video feedback of the burning field. Sensors which were used in this project were 5-volt sensors. Then the output voltage of the sensors was 5 volt. When installing sensors in the field, 12-volt input card was designed to prevent voltage drop with the length of the signal wires. This is the voltage switching process of sensors to microcontroller unit. This is the 5-volt sensor. It turns on relay and this relay switch 12 volt to 12 volt input card. 12 volt input card convert 12 volt to 5 volt again and send to microcontroller. These optocouplers are used to separate 12 volt and 5 volt side. These are the pictures of prototypes. This is field system with Arduino Uno and this is fire control unit system. To determine threshold values of the sensors, 6 gas sensors are used. Threshold value is a level or limit on a scale. When threshold is reached, something else happens or change. In this case, threshold value is the sensor value at smoke is detected. Area A shows heating stage of the MQ series gas sensors. According to graph, heat of time 330 seconds to 360 seconds. Area B shows sensor values in clean air, and area C shows sensor value at detection of smoke. 250 and 300 values used as MQ2 sensors threshold value, and 600 to 650 value used as for MQ135 sensors. Infrared and passive infrared sensors for flame detection. IR sensors have onboard potentiometer to adjust sensitivity. Using these potentiometers, sensors trigger point sets to trigger in 200 lux flame intensity at 1 meter distance. PIR sensors adjust to trigger at 7 meter in 200 lux flame sensitivity. Testing GSM module for send and receive fire alert. After the SIM 800L module sent the fire alert and SIM 900A module received the fire alert. The LCD display successfully shows GPS coordinate of burning field and turn on the area indicator on relevant field. These are the implications and limitations of this project. As the implications, used as a fire detection and prevention system in the agricultural fields, animal farms, homes, office complexes, and warehouses. Used for controlling wildfire in national parks like Redwood National Park, California. Used as an irrigation control system. The limitations of this project are initial cost is high for install at the field. Need technical knowledge to install the system and need clean the sensor twice a month to remove dust. This is the end of my presentation. Thank you all.
Okay. So now it's the time for the questions and answers. So the participants can ask questions. Make the questions here to be answered. Shall I ask the one question, one or two questions? That you are installing this microcontroller in the field, no?
Yes, sir.
Sanaga, right?
Yes.
So then how can you power the microcontroller, the whatever the installation in the field?
Solar power and national
Solar
grid, sir.
power. National grid.
Oh,
What do you mean by solar power, national grid? What do you mean by that? There are two things.
if not national grid, we can use solar power.
Instead of, right. And yeah, you mentioned in the presentation the PIR sensor figured at 7 meters, no? You
Yes,
mentioned in there. Yeah. That means the PIR sensor is located in 7 meters. So what does that mean?
PIR sensor can detect fire at 7 meter distance in 200 lux fire.
Yeah, that's the flame intensity.
Yeah.
Yeah. So then what would happen the lesser than 7 meters? It does not sense. It means
No, sir.
how do you decide that 7 meters? That's what I want to ask.
200 lux flame move to the sensor to a distance out of sensor.
So experimentally, you found that, no?
Yes, sir.
Right. So the other question is that the wireless communication is done between the field system and the whatever the monitor.
Air control unit system.
Right.
Yeah.
Sanak, I also have one question. Now, have you checked this in the field, or is this only a prototype testing? What's the development? Have you done this in the field at this moment, or yeah?
Yes, sir. We done in field
Okay.
for
Now
few
in the
trials
field
only.
trials. Okay. It has been successful, no?
Yes, sir.
Yeah, I think you said that now the dust controlling is the issue. It is a
Yes,
concern. Yeah.
Yeah.
Now, can you elaborate it a little more? What's really problem? What's the real problem there with that?
Smoke sensors blockage, sir.
With the
dust.
dust. Okay.
Yeah.
Can it make a false alarm also with the
Yeah.
dust?
No, sir.
No.
Not operating only.
Not operating. Okay. Then it may not check.
Yeah.
Now, time to time, you have to clean it. If not, it may not function in the as you
Yes, sir.
expected.
Yes.
Okay.
The other limitation is the cost, Mr.
Yes, sir.
Sanayaka. Yeah.
Yeah, sure.
So, do you have any idea to somehow reduce the initial cost?
Yes, sir. We can make the sensors by connecting parts doing separately without buying whole component. I mean, already made sensor.
Like a module wise.
Yes, we can assembly it.
Then price can be
Yeah.
slightly reduced, right?
Yes, sir.
Okay, thank you very much for answering the questions.
Thank you.
I think that there are no more questions.
Thank you.
Yeah. Okay. Thank you, Mr. Sanayaka, for presenting the new invention. Okay. Thank you very much. Right.
You're welcome, sir.
Right. So next paper is paper ID number 48. Development of humidity sensing material using zinc oxide doped derived charcoal from the waste polyvinyl chloride. So there are three authors in this extended abstract: GDK Heshan, Dr. Sanjeeva Vijayasinghe, Danushka Madhuanta, and Professor RMG Rajapaksa. Mr. Heshan, GDK Heshan, is presenting. You can hear now his presentation.
Good morning, everyone. My research topic is development of humidity sensing materials using zinc oxide doped charcoal, which is derived from waste PVC polymer. I am from Slintec. I have already registered in postgraduate institute in the Science Fair at the University as a PhD candidate. These are the contents of the research: introduction, background and motivation, methodology, experimental, research and discussion, conclusion, and references. Introduction. In introduction, the humidity sensor is a device that sends, measures, and reports the relative humidity value of air or the controlled area, and it presents as the water vapor present in gas mixture or biogas. Second, background and motivation. Normally, humidity measurements are used in various industries for storages and also ongoing production. Mainly, we can see large amount of humidity sensing applications in agriculture field and food industry. Also, medicine and other industries also use various kind of humidity sensing applications. In also other hand, there are new trends in finding new materials which are capable to sense humidity. On the other hand, PVC polymer is as a waste. PVC has a long shelf life because it is very difficult to deteriorate or decompose this polymer somewhat near 100 years. So there's a high impact into environment when the polymer is entered to waste stream. It is good if we can convert or pyrolyze PVC to prepare conductive carbon material, which is used as a humidity sensing material. Methodology. In this research, we use waste PVC and we doped with zinc oxide. We pyrolyze the PVC at the argon environment to 600 Celsius, and hydrothermal treatment was done to prepare zinc oxide nanoparticle on the surface of the PVC polymer. Using this composite material, we prepare electrode, which is act as the sensor. The two electrodes will contact with the prepared polymer composite material. In experimental, we use to determine several physiochemical characterizations in the material. Also, we use humidity sensing performance investigation to determine the sensing properties. As physiochemical characterizations, we use scanning electron microscopy for determine the morphology of the prepared material, and X-ray diffraction spectroscopy, and for the thermal profile, thermal gravimetric analysis, and to determine the graphitization, portion of graphitization, Raman spectroscopy. Next one is results and discussion. We can see the results for the XRD and FTIR spectroscopy. The first graph, figure 1, first graph A, we can see the heat treated PVC, and for B, the raw PVC. We can clearly see the graphitization is happened due to the thermal treatment. Also in FTIR, near 1243, we can see the in graph figure 1D graph, raw PVC had Cl bending bond, and after heat treatment, the Cl is removed as HCl and prepare and generate the cyclic structure, which is conductive. We cannot see the Cl bond in treated PVC sample. Next, TGA analysis, thermal gravimetric analysis. The first graph A shows the used PVC, which is different from standard PVC. The standard PVC curve is shown in figure B. This will happen due to the fillers, plasticizers, like other impurities in waste PVC. You can clearly see the HCl removal in region 350 to 450, huge mass loss on the TGA curve. This is due to the dechlorination. Normally this happen near 450 and 850 Celsius in PVC polymer. Next, we can see the Raman spectroscopy. We have done two analyses. First one for the prepared carbon in A, and the second one for as a comparison. We compared with the raw graphite sample. You can see 2D to G ratio is 0.422 for the graphite, and for the prepared PVC sample it is 0.22. With 2D to G ratio we can say the conductivity value. As seen in this figure, we cannot see higher conductivity than the graphite, but it is significantly high than the raw PVC. The next we can see the sensing performance. In first graph we can see the desorption and absorption curve for full cycle for the polymer. In graph A, it takes at least 30 minutes for 15.5 for the desorption, and the absorption will take again 15 seconds. This is good value. Also we can see in B the stability within 25 hours. For each sensing can see good stability. In graph C you can see the response. It is this between 31 to 95 RH limit. We can see good response with good repeatability. And graph D shows the resistance change within humidity amount. We can see good linear change for the resistance. Conclusion. As conclusion, we can say waste PVC charcoal and zinc oxide can be used effectively for the prepared low cost and high performance humidity sensors, and also it shows good repeatability and wide response. With normal sensors we can see the upper level or the lower level in relative humidity sensing. For the titanium dioxide like semiconductor sensors, they normally show in upper level, and tin oxide they normally show response as lower level, but in this material we can see total good range in humidity sensing, and also 24-hour response value is good as references. These are my references. Thank you for listening.
Okay, right. Okay. So now our participants can ask the questions. Are there any questions? Right, Mr. Heshant, where do you find this the waste polyvinyl chloride?
Used plumbing materials, waste plumbing materials.
Is that the mass scale production? Do you think that the waste, the raw material is good enough? Mass scale production.
Yes, sir, because in one humidity sensor it will go 15 micrograms amount of material to prepare one sensor.
No, I'm asking the I am asking the raw material, waste PVC. Is it available in large amount?
Yes.
Large amounts.
Yes.
So then my next question is that so there are these humidity sensors available in the market, conventional things. So
Yes.
your one is the something alternative, the solution basically focused on improving the cost, right? Production cost to be reduced, and the performance wise, no?
Yes.
Those are the, I think that two areas you are focusing. Have you compared the cost of the production, the conventional one, and your new invention? Have you compared the sensing parameters and the performance of the conventional one and your new one? Have you done some comparison?
not with the cost, sir, but
Yeah.
according to the
Parameters and performance.
performance, it will good, because normally in commercial sensors it will show 30 to 50 seconds for the response, but our sensor uh, show the 15.5, near 15 seconds of response.
15, 15.
15 seconds.
50. Right. Okay. So then, is there any reason to use the zinc oxide, drop the zinc oxide?
Yes, because it will enhance the sensing performance. And also, if we use normally zinc oxide used as a sensing material, but we can use solo as a zinc oxide as a solo, because it will not give the response that we need. And also, the zinc oxide show response in sensing at near 35 to 75 region of relative humidity. But when we use the composite material, we can expand the region of sensing region.
You make the composite, no?
Yes.
So then from the waste PVC, then how do you make the composite?
We use waste PVC and then crushed it to powder. Then we placed in tube furnace to give control environment, and we give argon flow and pyrolyze it to 600 Celsius temperature. After that, we get the charcoal sample, mix it zinc oxide, and again we put it in the hydrothermal reactor, hydrothermal pressure chamber, and use the hydrothermal reaction at 140 Celsius. When it slowly cool down, the zinc oxide nanoparticle will grow on the surface of cavities and micropores on the prepared pyrolyzed charcoal surface. After that, we can mix it with PVDF4 binder, and then cast it and use as a electrode.
It means that the zinc oxide you are using as a nanoparticles, right?
Yes. Between not sometimes we due to the hydrothermal process, cooling down process, we can use nanoflowers, nanoparticles, nanorods, or nanoflakes like such structures by the controlling the environment or the cooling temperature.
Right. So, are there any more questions from our participants? Okay, it seems there are no questions. Thank you, Mr. Heshan.
Thank you, sir.
Your presentation. Okay, right. Thank you very much. Right. Right. So next paper is paper ID number 50. Development of humidity sensing material, 50, preparation of flexible electrode composite material with expanded graphite and PVAC, polyvinyl acetate. Right. So there are 4 authors in this extended abstract. Mr. GDK Heshan, Danushka Madhuanta, Dr. Sanjeeva Vijayasinghe, Professor RMG Rajapaksa. So you can hear now the recording of the presentation from Mr. Heshan.
Good morning, everyone. My name is GDK Heshan. I am from Sri Lankan Nanotechnology Institute, and I am also a student in Postgraduate Institute of Science. My research topic is preparation of flexible electrode materials, composite materials with expanded graphite and polyvinyl acetate polymer. Introduction. Flexible electrode. Normally flexible electrode that must be thin, flexible, and easy to adjust to the for each application. Normally they use flexible materials for preparation of flexible electrodes. Most of these materials are not good for environment. Also, they are biocompatible, but also not likely degradable. There are several examples for electrode materials, flexible electrode materials, metal-based materials, carbon-based, polymer-based, and micro-pattern materials. Background and motivation. Normally, we use these flexible electrodes as in the component of textiles or wearable electronics such as smartwatches and belts like things. Smart textiles and wearable electronics are an emerging fields in science and technology in this era. Methodology. We can see the schematic illustration of the preparation of expanded graphite from natural flake graphite. We use the graphite from Kahadagaha. Firstly, graphite must convert to the powder after pulverizing process using ball mill or disc mill. After that, we use acid mix for the graphite and the thermal expansion assisted with chemicals are done using controlled tube furnace under 600 Celsius temperature. In the temperature, the chemicals will react inside the structures, layer structure in the graphite, and they convert to expand. This will happen between 3 or 5 minutes time. It is very quick process. The mixing of PVC and acetic acid to generate the composite material, we must mix the graphite with flexible material, which is in this study the PVAC, polyvinyl acetate. For polyvinyl acetate, this is not dissolved, it cannot dissolve in water, but can be dissolved in acetic acid. We wash the graphite and then mix with PVAC and acetic acid to mix. After the drying process, in the drying process, we use thin layer of PVAC excited graphite layer and use Teflon sheets because the Teflon sheets withstand 120 Celsius, and then we put in the hot plate for evaporate the acetic acid. After the evaporation, we can take the thick film of PVAC and expanded graphite polymer using press. We can prepare thin films of expanded graphite and PVAC composite material. This is the final product. We can see flexibility of the final product. As experimental, we try to analyze the polymer material with for the specific characters which can use as a advanced we can use to prepare advanced type of flexible electrode material. First one is resistance change with increasing moisture, because we use in if we use in the moisture full surface like sweat or water, that must be, we must check the resistance change. Also the compression load, because the in flexible materials the wear and tear is high. The third one is resistance change with tensile stress, and also we compare the resistance change with PVAC composition also, because with higher PVAC composition, that means the exam graphite ratio is low, that will tend to decrease the conductivity and increase the resistivity. Also the resistance with increasing moisture, because after the adsorption of moisture, that will also affect to the conductivity of the composite material. For the expanded graphite, we done the FTIR analysis, XRD analysis, Raman analysis, bed surface area analysis, and scanning electron microscopy analysis. These are my abbreviations. Resistance after the strain of the after the applied load, the best VVAC composition PVAC to graphite ratio is 1 to 3 for mass ratio. We can see two graphs. First one is the resistance after 25 load. The first graph is resistance before 25 load, which means the resistance value increase after the applied load. This may happen due to the compression of the materials inside the composite. The figure 3, you can see the resistance change with the applied load. When we applied the load, the graphite structure will come close and the resistance will gradually lower. The figure 4, we can see the resistance change. The change in the you can either stress with megapascal values and also the strain. After the small amount of strain, the structure will lose the conductivity, and after sometimes the structure will fail. We can see the graph from the figure 4. The point, we can see the point is 0.04993 strain. This small area is expanded in figure 5 with the change of the resistance and strain with the applied stress. We can clearly see after specific point the material will lose the conductivity and become resistance. This is the in figure 7 we can see the resistance change after as water moisture absorbance. In figure 8 we can see the FTIR spectra of the graphite and expanded graphite. We can see the significant peaks which can be allocated to the expanded graphite and normal graphite. At figure 12 we can see the change of the G peaks and the D peaks of raw graphite and the expanded graphite. We can see the expanded graphite, the ratio is decreased. The final graph, we can see the XRD peaks of the expanded graphite and natural graphite. In this figure 14 we can see the decrease in surface area after increase in surface area after the expansion or exfoliation process. The first value for the raw graphite is 2.85 square meters per gram, and it will increase to 5.184 square meters per gram. These are nitrogen absorption as the plots. Also in figure 15 we can see the surface morphology of the expanded graphite and raw graphite. The first image we can see the we can see the low amount of flake-like structures in surface, but after the exfoliation we can see the high amount of flake-like structures in expanded graphite. In conclusion, in first slides I didn't go through the concentrations and the weight ratios of the chemicals we used for the in the reactions. The HClO acids and also the nitric acids we used for this research. We take the natural flake graphite HCl4 and nitric ratios 1:42 and 0.15 ratio, and also the temperature is taken 1173 kelvins for 15 minutes for the exfoliation process. And also there are several past studies on the exfoliation using acids, but in our system these are the optimum ratios. Also this give the maximum expanded volume of the graphite for 480 square cubic centimeters per gram, in this study. The lowest resistance obtained from this was 0.635 ohms, and the material ratios Eg to PVAC was 1 to 2.5. The pressure is applied at that compression is 40 tons. Thank you.
Okay. Now our participants can ask the questions from Mr. Heshan. Okay, Mr. Heshan, shall I ask several questions? Is there any reason to specific reason to use polyvinyl acetate? And
Because
yeah,
when there's a trend in preparation of low toxic electrode materials, normally we use as a binder PVDF, like binder Teflon, like binders. They are very toxic binders. Also, it is very difficult to degrade. But PVAC, polyvinyl acetate, is better than that, and also it is dissolved in water. Because
yeah,
of that, we can
polyvinyl.
use because we can use in aqueous electrolyte for our applications while using this kind of electrode material. Normally, commercially, there's a material, the product name graphoil, that is prepared by expanded graphite, but they applied more pressure, compressive force to prepare that in roller mills, like 100 or 150 tons. And this material is water soluble, hydrophilic material. That is another disadvantage
Advantage.
of of that material. But our material, it didn't dissolve, but there is a slightly water absorbance in PVAC polymer. Because of that, we analyze that using various moisture levels to determine the resistance change while absorbing the moisture.
Yeah. In your presentation, you said that the PVAC is a base material that you are taking. One is from the wearable, the whatever electronic items, or the from textiles. What do you mean by from textiles?
Normally, when we using textiles, we use some textiles or wearable items, means like shoes. We can place pressure sensors. In that type of applications, we must design materials, not the sensitive material. Also, electrode must be flexible with the material. For this kind of application, we can use these systems.
Right. So the previous research have been conducted using the nitric acid, no?
Yes, nitric acid, also
And
sulfuric acid, but we in this system we use nitric and perchloric. We done for all acids, but in this research, this abstract, we use perchloric and nitric acid.
Is there any reason to be improved the previous findings? That is what you are using.
Yes,
the mixture of the nitric.
Yes, because if we use perchloric acid, the exfoliation is very powerful than sulfuric acid. Also, the cost is for the perchloric acid is very high. And if you use sulfuric acid, low grade sulfuric acid, they are another risk that contain lots of impurities from the acid. But if you use perchloric, the impurities will be less.
Do you think that your product is biodegradable?
Not completely, but it is biodegradable, not biodegradable, degradable than the normal commercial products.
Right. Okay. Are there any more questions from our participants? I think there are no. Yeah. Yes, thank you, Mr. Ishan, again. That your
Thank you,
second
sir.
presentation, right? Okay, thank you. Okay, so then our last presentation is regarding the producing a cement block with sustainable use of polyester yarn waste and determining optimum mix. There are 4 authors in this extended abstract. Mr. Saman Vijayawardena, Mohammed Suhail, Udara Pereira, and Mr. MHV Rohan. So you can hear now the presentation is from Mr. MHV Rohan.
Hello, good day to everyone. My name is Vimukti Rohan. Today I am going to share with you the findings from the research that my team and I conducted on producing a cement block with sustainable use of polyester yarn waste and determining optimum mix proportion. Introduction. Allow me to begin by providing a brief overview of this research and the purpose behind it. A significant threat to the environment is posed by the 30,000 to 40,000 tons of textile waste produced by the Sri Lankan garment industry each year. Much of it is made up of synthetic non-biodegradable polyester. The proper disposal of waste, which is the result of several activities, has become one of the main global challenges in recent decades. This study was done to investigate whether it was possible to make cement blocks that were advantageous in various ways by using polyester yarn made from textile waste. Aim and objectives. If we generalize our aims and objectives, it would look like this. For the aim, it is to investigate and determine the optimum mix proportion to produce cement blocks with sustainable use of polyester yarn waste. As for the objectives, it is to evaluate and compare the suggested block's compressive strength, moisture content, water absorption, block density, and split tensile strength to those of standard blocks. And the other one is determine the ideal mix proportion to achieve maximum use and future development. Methodology. This is a brief of our methodology to achieve the objectives. For the materials, corridors that compiled with SLS 882 and was free of hazardous materials was used as the aggregate, while regular Portland cement that compiled with SLS 107 was used as the bind. In the research experiment, polyester yarn in the form of thread was used as a direct textile waste. Following a series of preliminary tests, the ideal cement to sand mix proportion, which is 1 to 10, was chosen based on which mix proportion gives adequate strength while being the most cost effective. In place of the aggregate polyester yarn with a content ranging from 0.1 to 0.5% was used based on earlier research on the creation of concrete paver blocks. Selected yarn pieces range in length from 3 to 6 mm and had densities of 1.15 gram per cubic centimeter. Blocks made with a cement sand block forming machine underwent the necessary testing. Sample preparation. Using this diagram, I can explain the general process for making a cement block. As you can see, it begins with the preparation of the basic ingredients, then involves blending particular substances with fiber. For a uniform consistency, it is crucial to thoroughly mix both before and after adding water. Using a block casting machine with the appropriate vibration, output samples can be generated by placing the mixture on the machine. We have created the appropriate samples in accordance with the methodology to conduct the research and test the effectiveness of cement blocks for various purposes. Blocks were assessed using several tests in accordance with SLS 855 standard. Compressive strength has a significant impact on the performance of cement blocks and ensures the general quality of the finished product. The minimum recommended compressive strength value for one-story building is 1.2 Newton per millimeter square. The maximum compressive strength value was 4.5 Newton per millimeter squared for blocks containing 0.4% yarn as seen in the graph, which shown how strength varies with the fiber content. Additional compression testing was done on blocks with 0.4% yarn substitution after 2 days of curing, and the early strengths achieved ranging from 1.7 to 2.1 Newton per millimeter squared. Water absorption test. As for the water absorption test, testing for water absorption on cement blocks is done to evaluate the block's weather resistance and other durability factors. SLS 855 Part 1 establishes 214 kg per cubic meter as the maximum permitted value for water absorption. As in the graph, no blocks exceeded the permitted threshold for net volume absorption. The highest number for water absorption was 213 kg per cubic meter with a yarn inclusion of 0.3%. Moisture content test. Considering the moisture content test, the maximum moisture content value was restricted at 40% accordance to SLS 855 Part 2. The moisture content increases as the fiber concentration increases from 0.1 to 0.5 as shown in the graph. The graph shows that none of our samples, regardless of the mix ratios, fail to meet the SLS 855 maximum level. Density test. The density test reveals that a denser cement block often offers more strength and fewer voids and porosities. According to SLS 855 Part 1, the maximum and minimum allowed values for block density are 2,800 kg per cubic meter and 1,000 kg per cubic meter respectively. As seen in the graph, there are no significant changes in density caused by variation in the yarn percentage. All of the block density values fall within the permissible range. Split tensile test. SLS 855 does not recommend conducting any tensile test on cement blocks when it comes to the split tensile test because masonry walls are not expected to carry any tension. Testing was done to determine whether adding yarn improved the tensile strength that could be used in future applications. As illustrated in the graph, the test result revealed that 0.3 addition of yarn yields the highest value, which equals a 100% increase over the control sample. We have come to end of our presentation. Conclusions and recommendations. We have reached several conclusions based on prior findings, which I'd like to highlight. The test findings showed that the characteristics of a typical cement block were not adversely affected by the introduction of polyester yarn. The incorporation of polyester yarn into cement blocks will be able to divert yarn waste to the building sector as a long-term solution to the problem of disposing of polyester yarn waste. The block can be utilized for load-bearing walls and the other reinforcing applications since the compressive strength can be enhanced by 73% at 0.4% fiber mix fraction. Cost effectiveness is achieved by strengthening our block while maintaining a low cement to sand ratio. Based on the results of this study, future researchers are recommended to create further applications for yarn in products such as precast wall panels, ceiling boards, etc. Thank you for everyone who has listened to our presentation. Now it's the time for questions if you have any doubts about this work.
Yeah, okay. So the participants can ask the questions now.
Mr. Rohan, I have one question. Now, how did you mix these polyester particles with the cement? Now, do you have limit the particle size of the yarns up to a certain extent, or have they a limit for the mixing?
The polyester yarn length was to 3 to 5 millimeter length. And for mixing, we have to use the hand mixing method because the polyester yarn makes actually a chaos in mixing. But sometimes we can actually introduce a new method of adding a polyester yarn into this research.
Yeah. In workability point of view, you didn't find any difficulty, no? That you check any workability parameters during when you are mixing the thing?
No, no, sir.
Not really.
No.
But it was not, you were able to mix it well with the cement.
Yes.
Yeah. Now you said that the particle size is 3 millimeters, isn't it? I didn't get
3
the
to 5 millimeter.
3 to 5 millimeter. Okay. That is the length of the fibers, isn't it? Oh.
Yes, sir.
Okay.
Yes, sir.
Okay. Yeah. You took that out of from the waste of the garment industry, isn't it?
Yes, sir. Yeah.
Okay,
It was
okay.
in the Sinhorana factory.
Yeah, it is interesting research, I hope. Yeah.
Yeah, Mr. Rohan. Yeah. Are there any questions? Yeah, Mr. Rohan, that you just now said in the presentation also, you are taking the yarns from the textiles, no? Textiles,
Yes,
the
sir.
fabric. Right.
Textile waste.
So, waste, right. So you are taking basically, for an example, from the garment industry waste, right?
Yes, sir.
So then, but that garment industry, the fabrics that we make the garments not only from the polyester, right? So specifically that they are using the mixture of polyester, right? Cotton and polyester.
Yes.
So the yarns are coming like that. So in your research, you are stressed only the polyester.
Yeah. Sir.
So how do you select the materials that you are taking the textile waste only from the polyester fabrics, or what is
Yeah,
your,
sir. That is actually.
yeah.
Because in the factory, they were separated, the polyester yarn from their waste.
So if you have the mixture that you cannot separate, it's yarn itself has the two components, cotton and the polyester. You are specifically selecting the textile waste from 100% polyester.
Yes, sir.
Right. So
in your case, actually, you have not tried that mixing. It's only out of polyester, as Professor said, isn't it?
Yes, sir.
Okay. Okay.
Yeah.
Maybe interesting research purpose. I think we can maybe take the next. Yeah. Okay.
That's true. That's true. That's true.
We can go with the mix, maybe. Yeah.
Yeah. The reason why we didn't do it, that's because we cannot introduce more parameters, because if there are polyester yarn and other material, then there will be so much parameters.
Correct. I agree. We agree, but I think maybe if maybe in a future research, maybe we can think about mixing the thing. Yeah. Okay.
Yes, sir.
Yes.
Yeah.
And Mr. Rohan, in your presentation, somewhere some graphs you have the x-axis fiber percentage, and some graphs you mentioned the x-axis as the yarn percentage.
Yarn in the form of the fiber form, because that we actually collect the yarn as a fiber form. That is why it is.
I don't think that. So you are taking the yarns and put it to the paving blocks, no?
No, sir. The yarn actually, the form of the yarn is actually fiber form. We collected.
In a fiber form you collected.
Yes, sir. Yeah.
So in the compressive strength graph, I have seen that the fiber percentage. But in the split tensile strength, you mentioned the yarn percentage. That means two. I don't know what is the difference.
Actually, the actually apply me yarn as a form of the fiber form. It is a thread form.
Yeah. So if you are using the fiber, it's something else. Yarn is something else. I am talking about the textile point of view. So it's better to use.
I think the professor's comment is correct. I think maybe I think in all of your cases, I think you have used the fibers, isn't it?
As a thread form, not the direct fiber. Correct. As a thread form.
It's a yarn. It's a yarn.
Yeah.
It's yarn.
I think maybe the terminology is the issue.
Terminology is the issue. Better to correct.
Correct. Yes.
Yeah. Okay, Mr. Rohan, thank you very much your presentation. So thank you very much, right?
Thank you.
So today we have the 6 papers, 6 extended abstracts. So the 6 extended abstracts have been presented. Okay, thank you very much for all the presenters. And also I must give my sincere thanks to Dr. Nadir and the other co-host, Dr. Laksini. We will wind up the session. Again, I'm thankful for you all to participate for this presentation. Thank you very much.
Okay, thank you all. I think we are going to wind up the session. Thank you for the participant, Professor as well. Okay, thanks.